So what is IceVIC? IceVIC stands for Integrated System for Enhancing VIC Output. IceVIC is a cartridge for the Commodore 64. It's also a core that runs in an FPGA to produce digital video output. It works by watching the bus for VIC access and then turns that information into a picture. It can run on multiple FPGA devices, and in this video I'm going to show you it running on the Tang Nano 20K. Let's take a look at the hardware. We have an FPGA carrier board for the Tang Nano 20K. It's pretty simple and consists of level shifters to translate voltage levels, plus a few extras for variable pixel clock generation, and a pass-through port so you can use other cartridges at the same time. Let's take a look at installing in the machine. Installation is straightforward, but you do need to open up the machine and connect 3 wires between the CPU and the IceVIC carrier board. These are the Sharon, Hiram, and Loram signals, and they are required to accurately interpret memory accesses on the bus. I'll use 3 wires with female DuPont connectors attached to IC mini grabbers. Starting with character enable on pin 27, then Hiram on 28, and then Loram on 29. Just route the wires however you want. I usually do it like so. Plug in the cartridge, and then your HDMI cable. We're all set. Let's check it out. To verify you've done it correctly, you just need to try something that writes to I/O space with a non-default memory configuration. A simple example is the power-up sequence in Gianna Sisters. Without these wires, the screen will go blank when you hit the power-up. That didn't happen in this case, so we're good to go. The version I'm showing here can run on a PAL or NTSC machine, and the core will figure out which you have automatically and will adjust the pixel clock accordingly to ensure smooth scrolling. Note that only NTSC new VIC chips are supported. If you install on a machine with an NTSC old or a Dream VIC, the screen will just show red. The output of the Tang Nano 20K is 1280 by 720. For the best possible experience, I highly recommend newer OLED monitors like this, LG. Older monitors tend to easily exhibit image ghosting that ruins the experience. LG OLED TVs with game mode enabled makes for a dreamy experience. Next up, let's talk about adjusting the clock. For smooth scrolling, the FPGA's pixel clock runs at a speed to match the Commodore 64's frame rate. It assumes the Commodore 64's clock is set to a standard specification. If it is running too fast or too slow, you'll see the screen flash periodically when it readjusts the clock sync. If tuned properly, you should be able to run for many hours without ever seeing a sync loss occur. In order to tune the value, you'll need one of these anti-static ceramic screwdrivers. A metal one will interfere with the signal. Locate the variable capacitor near the clock oscillator next to the VIC chip. To adjust the clock, press the S1 button on the FPGA to bring up the on-screen calibration tool. The first number is the Commodore 64's clock speed. The measurement isn't perfect, but is close enough. On the second row, the first 3 digits are the line number that the VIC is on at the top of the FPGA's video frame. The second 3 digits are the same thing, but for the previous frame. When the clock is calibrated correctly, the second number is always 1 higher than the first. You want the numbers to be changing as slowly as possible to avoid losing sync. The last 2 digits keeps a count of how many times sync loss has occurred. Make ultra-tiny movements until you reach a value close to 985248 for PAL at 50.1 Hz or 1022727 for 59.826 Hz NTSC. Watch the effect on the second row and make sure the line number is decreasing, not increasing. I hope you enjoy your IceVIC cartridge. The firmware on the Tang Nano 20K can be flashed with updates, so watch this space. In upcoming videos, we'll also look at the same core running on other FPGA devices. Stay tuned.